cosines. The law of cosines is like an abstract Pythagorean theorem. So the Pythagorean theorem says c squared equals a squared plus b squared. Well, the law of cosines tacks on a minus 2ab cosine c. And this is true in any triangle, not only just right triangles. So notice in particular that if the 90 degrees were angle C, then this would actually cancel out because cosine of 90 degrees is 0, and you would have the Pythagorean theorem. Okay, so draw a quick sketch of a triangle here. I'm going to put A, B, C. We're given that angle C is 81 degrees, and we're given that sides A is 59 and side B is 36. So you can see that we're in an SAS conditional here, a side angle side. So for the first step, let's just apply the law of cosines. So we're going to be finding side C in this case. So C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of the angle C, which is 81 degrees. So I'm just going to type all that in the calculator. 59 squared plus 36 squared minus 2 times 59 times 36 times the cosine of 81, and that comes out to be 4,112.47-ish. And now when I take a square root, that's going to imply that C is equal to, I'm just going to take the square root here, to 2 decimal places all the way is 64.13. So we get 64.13 for angle, or for side C. Now that we know side C, we can use the law of sines to get either sine B or sine A. So with law of sines, I highly recommend, for reasons I won't go into in the video here, that you always find the smallest angle first when you're using law of sines if you're trying to use the sine part of it. So we're going to be finding angle B first because it's the shortest side of 36. So it's opposite the shortest side. So sine of B over side B, which is 36, is going to be equal to sine of C, which is 81 degrees, over side C, which we just found is 64.13. So therefore, sine of B is equal to 36 sine 81 over 64.13. So I'm going to type that in my calculator. 36 sine 81 divided by 64.13. Should get a number between 0 and 1 here, and we do that sine of B is equal to 0.5544. And so in order to find angle B, I'm just going to use the inverse sine function here. So inverse sine, or arc sine, that answer, and we're getting a 33.7 degrees. So for my angles, I'll round to a tenths place. So B is 33.7 degrees. Okay, nicely. We still have one more piece to do. You could use a law of sines if you wanted to, but since all the angles in a triangle add up to 180, let's just take the easy way out here and say all the angles are 180, subtracted by the 81 for C that was given, and subtracted by the 33.7 for B, which we found, we can find that angle A is going to be equal to 180 minus 81 minus 33.7, or 65.3 degrees. Okay, so why don't you pause the video and see if you can do the next one on your own. It should take about, took us about 4 minutes there. Let's see how long this next one takes. So there's your setup. Pause the video, try it on your own, and assuming you did, let's do it together. So A, B, C. All we know is angle B as 25 degrees for the angles, and for the sides we're given that A is 20 and C is 43. So to find side B, we're going to use the law of cosines. So switching it up, instead of the A, B, and C in the version before, we're going to be solving for B squared this time. That would be equal to A squared plus C squared minus 2 times A times C times the cosine of angle B, which is 25 degrees. And this really shows the importance of the labeling doesn't really matter, because now that these are not necessarily right triangles, calling C the 90-degree angle is not really important anymore, so you can switch them up to whatever sides you want. In the calculator, 20 squared plus 43 squared minus 2 times 20 times 43 times the cosine of 25 gives us a fairly large number, 690.15 stuff. And so B, when we take the square root, would be 26.27. 26.27. So side B, 26.27. Now for the angles. So again, let's go with the small angle. So we'll go for angle A. So now that we have that side B down here is 26.27, we can set up for angle A, which is the smaller one. We'll get sine of angle A over 20 equals sine of angle B, which is 25 degrees, over 26.27. So sine of A must be equal to 20 sine 25 degrees over 26.27, which would mean that sine of A must be equal to 20 sine 25 over 26.27, or 0.3217. So last step, arc sine here, arc sine the angle, and it looks like we're getting an 18.8 degree angle. Notice that's consistent. That's a smaller angle because it's smaller than 25 degrees, just like side B. Side A is 20, which is smaller than side B, which is 26.27. Okay, last thing is that last angle over there, 180 degrees in a triangle, subtracted by the 25 for B and subtracted by the 18.8 for A, is going to give us a big angle left over, right? 180 minus 25 minus 18.8 leaves us with 136.2, and so that is our last angle. Last angle is 136.2.